We're now going to start 2.3, and this is all about functions. Now, what happens with a function is something goes in, and it changes it to something else. So, a really good analogy of a function is a gas pump. Now, when we talk about a gas pump, we go to the gas station, and we put money in. And so whatever you put in, that is your X value. And then what do we get out? Well, we get out gallons of gas. And that's your Y value. So X goes in, it does some operation to it, and it gives you something else out. We do this all the time. Whenever you go to the store, you buy something, okay, your money gets traded out for an item. Something goes in, something different comes out. That's a function. When something goes in, something comes out. Now, what makes something not a function? And they don't always just go to one number. Like I like the gasoline pump analogy because if we go to the gas station, there are different grades of gasoline. We go to the gas station and we go to the gas pump. Again, we've got a gas pump, and we've got different grades of gas. So that might be 87, 89, and 91. Now they cost different amounts. So let's say the 87 costs $1.50. The 89 costs $1.60. And the 91, let's say that's $2. So these are different prices of gas, but either one that I pick gives you out 1 gallon of gas. So different X values can go to the same Y value, and this is still a function. So that's still a function. All these X values can go to different Y values. And that's a good illustration because we know if we go to the gas station, they've got different grades of gasoline. They cost different amounts. So if I put in $1.50 and I pick the 87, I get out 1 gallon. $1.60 of 89 gives me 1 gallon. And the $2 also gives me 1 gallon. And that can happen. So that's still a function. Now, where is it not a function? This one is not going to be a function. So this one is a function. The next one is not a function. And this one might be better explained with wages. Okay, so let's say I'm looking at wages. And let's say I get $10 an hour, and I work for 10 hours. Now, if you work for $10 an hour for 10 hours, how much would you expect to get out? Well, you should get out what? You should get out $100, right? $10 an hour should make $100. Well, let's say you got $100, but the other person got $500. Now, they worked the same 10 hours for the same $10 an hour. Could this happen? No, because that might be a mistake in HR, right? When they wrote up the paycheck, they made a mistake. You should have only gotten 100, but they miscalculated and they gave you 500. See, this is a mistake. And that's why it's not a function, because each X value must go to one Y value. not two different values. So if you work $10 an hour for 10 hours, you should get $100, not $500. If you got $500, then there's a mistake somewhere. They gave you extra money. Maybe they typed in the numbers wrong. They must have typed in 50 hours instead of 10, but they made a mistake. See, this is not a function. So what makes something a function is each x value must go to one specific y value. So each x value has to go to one y value. So that's why this one's not a function. Now, this one up here with the gallons of gasoline, why is it a function? Well, these are different x values, $1.50, $1.60, $2. They're different x values. They can all go to the same y value. But you can't have one x value split off two ways. So it can't happen. So to be a function, each x value must go to one y value. And we're also going to talk about the domain and the range. Now the domain is going to be our values of x. And the range, some textbooks call this the target. Ours calls it the range, so we use the range. The range of the target are the values of y. So the values of x are your domain. The values of y are your range. So we talked about what's a function, what's not a function. We've also talked about the domain and the range. Now I'm going to give you some ordered pairs here, and you're going to tell me what the domain, the range is, and whether or not this is a function. So this is pretty simple here. You've probably seen this before. So I want you to find the domain, range, and decide if it's a function. So here's some ordered pairs. How about 3, 5, 4, 8, 9, 5, and 2, -1. So we've got these ordered pairs here. We need to see if this is a function or not. And I like to check this visually. So I'm going to draw a mapping here. I think the mapping just makes it easier to see where everything goes. So for the mapping, 3 for my first one, that's in your x value, maps to 5, 4 maps to 8, 9 maps to 3, or sorry, 9 maps to 5, my mistake there. So 9 maps to 5, and 2 maps to -1. Is this a function, yes or no? How do we tell? Well, we can tell if it's a function by looking at the x values. Are any of the x values duplicated? No, they're all different, so that means this is a function. And the reason for that is, again, all the x values are different. What about the domain? Again, the domain is the values of x. We're going to list them from the smallest value to the largest. So let's look at our values of x. These are our domain. So we've got 2, 3, 4, and 9. So those are our values of x. And the range, or the target, is your y values. And if a number is duplicated, you just write it once. So that 5 is duplicated, so we only have to write that 5 one time. And again, we always start with the smallest number. So we've got -1, 5, and 8. So that's our domain, our range, and this one is a function. Let's try one that's not a function. Again, same directions as above. I'm going to give you some ordered pairs now. How about 4, 9, 5, 3, 4, 10, and 3, 1. So the same directions that we had above. I always like to make a mapping. I think the mapping makes it easier to see what we've got. So 4 maps to 9, 5 maps to 3, 4 maps to 10, and 3 maps to 1. Is this one a function? Yes or no? No. Why is this one not a function? Duplicate 4s on the x, right? Duplicated x values. So those duplicated x values mean that it then is not a function. Let's go ahead and get our domain and our range. For the domain again is values of x. We always write the smallest value first. So we've got 3, 4, and 5. Duplicated values only get written once. What about the range, the y values? Well, it looks like 1, 3, 9, and 10. So same directions as above. We said that this is not a function. We got our domain and our range. Okay. Now let's look at graphs. And for graphs, we have what's called the vertical line test. This is going to tell us if it's a function or not. So this is 4 graphs here. And we're going to use the vertical line test. And here's what the vertical line test says to do. You draw vertical lines. If any line touches the graph at more than one place, it is not a function. So that's our vertical line test. So we draw vertical lines, and if any line touches that graph at more than one place, then it is not a function. Domain again is the values of x. Range is the values of y. So I'm going to draw a graph here. And we're going to talk about this graph, and we're going to see if this is a function or not a function. And you're also going to give me the domain and the range. Well, first off, this graph, it's called a squaring function. We'll learn more about this later on. But this graph is a function. Why? Because if I draw vertical lines, each vertical line touches that blue graph at only what? Only one place. So this is a function. Now, what about the domain? The domain is the values of x. And this is your x-axis here. If I look at my graph, so I'm going to start here. If I look at my graph, what's it doing? It's going up, and it's going where? This way, it's going back to the left. If I go this way, it's going up, and it's going to the right. So as it goes to the left and to the right, it goes to positive and negative infinity. So my domain, the values of x, are in between negative to positive infinity because it's spreading out to the left and to the right. Now, what about the range? This is a little bit different. The range is your y values. Where does this graph start at? On the y-axis, it looks like it starts at 4. And what is the graph doing? It's going up. So my range would be 4 to infinity because it starts here at 4 and it's going up to positive infinity. Okay. And we'll do several of these graphs to make sure we understand the domain and the range. The function part is usually the easier piece. The domain and range is the harder part. So let's look at another one. And let's see if this one is a function or not. This graph here, do you think this is a function? It's pretty easy. If I draw my lines, each line touches the graph at what? Only one place. So that means this is a function. What about the domain? If I start right here, what is it doing? It's going up and to the right, and down and to the left. So if I look at this graph is going up and continuing over to the right towards positive infinity. This part's going down and continuing to the left to negative infinity. So my domain is negative to positive infinity. And my range is going to be the same thing because it goes up to positive infinity, down to negative infinity. So it is a function. Your domain would be negative to positive infinity. And the same thing with your range. The next one is not going to be a function. And we'll do a circle, because a circle is not a function. Now this will be more like an ellipse, but that's okay. All right, well, you still get the same idea here. It's more or less an ellipse, not quite a circle. But this one would not be a function. Why not? Can anyone tell me why this one would not be a function? Yeah, if I draw a line right here, what happens? That line touches it more than one place. That line touches twice. So if you draw a vertical line and it touches that graph at more than one place, then it's not a function. Now, what about the domain? Okay, the domain is the values of x. And this ellipse here is stuck between what? Well, this ellipse is going to be stuck between, it looks like, minus 2 to 4 on the x-axis. What about the range on the y-axis? Well, on the y-axis, it looks like it's going to be about what? My graph is off a bit, but it looks like it's about minus 3 to what? To 3. Because the range is the y part, the up and down component, and the domain is the x component. So the up and down is your y, left and right is your x. And this actually comes out to be a circle. It looks more like an ellipse, but it's actually a circle. If I were to draw it correctly. There's your domain, negative 2 to 4. Your range is negative 3 to 3. And with those numbers, you always use a square bracket with these. Now let's talk about increasing, decreasing, and constant functions. So when we talk about increasing, that means it goes up from left to right. The decrease part goes down from left to right. And the constant part, if there is one, stays the same from left to right. We can have a function that has an increase part and a decrease part, or it might have an increase, decrease, and a constant part. It might have all three. Now, when we look at increase, decrease, and constant, we label, very important here, label on the x-axis, not the y. So you're going to label this on the x-axis, not the y-axis. So I'm going to give you a function, and you're going to tell me where this function increases, decreases if it does, and is constant. And it may not have all three, it may just have two of them. Okay. So let me just draw something here. Now, when we label it, we have to label it off of the x-axis. 1, 2, 3, 4, and about 4 again. So here's our function. Now, when we look from left to right, and we read it from left to right, and we look at our picture and we see what's happening. So as we read it from left to right, we start up here on the left, and what's happening? As I follow this graph, this is going down, so that would be a decrease. Then we have a constant. We'll use a C for that constant. And then when it hits this point, what does it do? It increases, doesn't it? When we label this, we have to label it, again, based on the x-axis, not the y-axis. So it has to be labeled on the x. So don't worry about the y, just worry about the x part. So we've got to see where it decreases, increases, and stays constant. So where is it decreasing from? Well, it looks like it's decreasing in this area right here. Okay, this is our decrease. Label on the x-axis. So it looks like it's decreasing from about negative infinity, because on the left is negative infinity, to the right is positive infinity. So it's decreasing from about negative infinity And where does it stop decreasing at? At about -4. So it decreases from -infinity to -4. And then it's constant. So the middle is constant. And where is it constant from? It's constant from about -4 to 4. And then where does it increase from? Because again, label on the x-axis. So this is your decrease. This is your constant part again. This is your increase part. And we label on the x, not the y. So where is it increasing from? It's increasing from about 4 to what? Positive infinity. And for the numbers, we use a square bracket. Infinity always gets parentheses, just like any other infinity on a number line. Let's look at another one. Yeah, we'll just draw this one here. This will be easy as well. Let's see. 1, 2, 3, 4, 5, it looks like. 6, close enough. Okay, so again, this one, now it's a little bit different. Again, where do we start at? We start at the left and we work our way to the right. So we start on the left side, follow the line. Think of it like a roller coaster. Okay, so the roller coaster's here. Roller coaster's going up, so that's an increase. Then it hits a spot here to level out, so that's your constant part. And then it starts to go down. So it increases, stays constant, and then it decreases. So let's figure out where it decreases, increases from, and stays constant. Well, where does it decrease from? Okay, we got to watch where it decreases. That's over here. And so it looks like it decreases from 6 to positive infinity. So this is positive infinity. This is negative infinity back to the left. So it decreases from about 6 to positive infinity. And we can do however you want to label them. You just got to get all three labeled. Where does it increase from? Well, it looks like it increases from negative infinity to about what? On the x-axis, that's this part. And that's negative infinity to about 5, isn't it? Always label off the x-axis, not the y. So don't even worry about the y, only worry about the x. And where does it stay constant from? Well, it stays constant here in the middle. And that's going to be from about -5 to what? To about +6. We'll do one more, and then we'll talk about our homework. So let's look at one more here. All right. So what do we notice about this one? Well, if we start up at the top, it's decreasing here, and it's decreasing there. Does it ever stay constant? Does it ever have a flat spot? Nope. Does it ever go back up? No. So what about the decrease part? Where does it decrease from? Let's get that first. Well, it decreases everywhere. So it decreases from negative to positive infinity. What about the increase part? Is there an increase part at all? No. So that would be none. It never increases. So that's none then. What about the constant part? Is it ever constant? Nope. So that's none as well. So that one decreases everywhere. Never goes up, never stays constant. What about your homework? Now, we did cover quite a bit of material today. So your homework, you should be able to do all of 2.1, all of 2.2, and 2.3, we didn't cover it all, but we did all the graphs, and we talked about the domain and the range. So for 2.3, you should be able to do question 1. Let's see, question 4. We haven't talked about those yet. And 9, 9 and 10. I don't think there's any others that we've talked about yet. We'll have to do the equations and expressions next time. So you should be able to do 1, 4, because that's an increase-decrease type of function. You should be able to do 9 and 10 as well. So that's going to be your homework for next class period. And again, I'll have the notes posted with the lecture.